corresponding viewers. This is Frockel Show welcoming you yet again, but this time Frockel Show wants to go through a lecture or a CBET lecture for a course which is known as ICT Technician Level 5. In ICT Technician Level 5, they are supposed to do a unit which is known as Develop Computer Program, and this is what Frockel Show is out to teach. We start by looking at what is expected after one learns this course. So if we look at this, you see we have, by the end of this chapter, the learner is expected to describe the steps involved in solving a problem using a computer, and then be able to represent the algorithm to solve a problem in flowcharts and pseudocodes, and then be able to describe and differentiate the types of programming methods. Then after we are through with that, then of course we now go to the first part which we are supposed to look at. Now on this part, we're asking, what is a computer programming methodology? So we start by basic definitions, and the first one is computer programming methodology, which in our case we can say it's a system of methods with its orderly and integrated collection of various methods, tools, and notations. And a computer program is a series of instructions written in the language of the computer, which specifies processing operations that the computer is to carry out on data. It is a coded list of instructions that tell a computer how to perform a set of calculations or operations. Then the other definition we have to look at is, what is programming? And we would say that programming is a process of producing a computer program. And programming involves the following activities. Number one is writing a program. Number two, compiling the program. Number three, running the program. Number four, debugging the programs. The whole process is repeated until the program is finished. Then we look at the problem solving with computer. How do we solve problems through computers? Now, there are a number of concepts of relevance to problem solving using computers, and two particular concepts which we shall consider. One is computability and complexity. What we mean here is that computability is a computer able to do that. For example, there are some things that computer may not be able to, like trying to feel mercy on someone, trying those emotional actions. The computer may not be able to compute them, like crying on behalf of someone, like trying. So then the nature of the problem, is it within the manageable resources of the computer? And we say a problem is said to be computable if it can, in principle, be performed by a machine, and some mathematical functions are not computable. The complexity of a problem is measured in terms of resources required, time, and storage. In other words, we are looking at the memory space of the machine, the processing speed, and of course, we are looking at also the time you take, and of course, how you store it. Then quickly go through the steps involved in solving a problem using a computer. We have a number of steps. Step number one is define the problem. State in the clearest possible terms the problem you wish to solve. It is impossible to write a computer program to solve a problem that has been ambiguously or imprecisely stated. Step number two is devise an algorithm. And an algorithm is a step-by-step procedure for solving the problem. Each of the steps must be a simple operation which the computer is capable of doing. Universally used representation of an algorithm is a flowchart or a flow diagram in which we use boxes to represent procedural steps which are connected by arrows indicating the proper sequence of steps. In many problems, you will need to define a mathematical procedure expressed in strictly numerical terms, since the use of the computers to do higher level analytical processes such as solving algebraic equations. Then we go to step number 3, is to code the program. You have developed an algorithm, now you code the program. The steps in an algorithm translated into a series of instructions to the computer comprise a computer program. There are many languages in which computer programs can be coded, each with its own syntax, vocabulary, and special features. Step number 4 is debug the program. After coding, most programs of any length don't work properly the first time they are run and must therefore be debugged. Often, during the debugging phase, errors and ambiguities in the original statement of the problem reveal themselves, calling for basic revisions in the solution algorithm. Then step number 5, you run the program. After the problem has been fully debugged, you run it, possibly using many sets of input data. This step may take anywhere from a few seconds to many hours, depending on the complexity of the problem and the speed of the computer. Then we go to step number 6. You analyze the results. Often the output from a computer program requires considerable further analysis. In some cases, even though the program worked perfectly, you may find that you solved the wrong problem. This will be discussed further in what we are looking for as logical errors. There is an acronym well known to computer users, GIGO, which stands for garbage in, garbage out. You don't give computer garbage and then you expect it to give you otherwise. It will still produce garbage.
Learning what's new with open minds, we engage and explore. Look or show, we inform. In wisdom we store. Through words we teach, and insights we proclaim. Together we grow, seeking knowledge flame. Lecture show, we share lessons in the air. Learning what's new with open minds.